So let's look at our bell work. It says, no one explained the formula and variables of the vertex form. Why is it called the vertex form? Because if it's in this form, we can quickly pick out a vertex. What is it? It's HK, right? So it's very easy to get your vertex from this. You use the vertex to create the formula, or vice versa, you use the formula to get the vertex. So it says, explain the purpose of the vertex form in your words, and I just quickly said that. You should have more than that. Something to that effect. What shape does the formula make? It makes a parabola. Write your own equation in vertex form and graph it. Well, if you did your homework, you did that 9 times last night. With someone else's, of course, but this should not have been any stretch for you to create after doing the homework. So, explaining your own words how you graphed from the equation. So, if I have an equation, f of x, I'll just make one up here, equals, let's do 2 times x minus 1 plus 3. There you go. I just made up an equation. So we know the original formula is a times x minus h plus k, right? So that means that a is equal to 2, h is equal to 1, and k is equal to 3. Well, I can pluck my vertex out of here because we know the vertex is equal to h comma k, right? So that's going to be 1 and 3. Someone asked me earlier, why isn't it negative 1? Because the original formula is x minus h. Okay, so that means that h must be equal to 1 to have this. So we've got our vertex. So how do we graph that? Well, we know so far we've got a vertex of 1 and 3. So over 1, up 3. Let's look at our a value. A is positive, so we know it's going to be a right side up, or a smile parabola. A negative makes a frown, an upside down parabola. But we know this one's positive, so it's going to be right side up. Or opening upwards is probably the more proper thing to say. But we don't know exactly, is it going to be a really wide parabola, really skinny parabola? And this is where I have trouble with your homework. It's like, you're just guessing. You're just picking a vertex and going with it. You've got to calculate some values and show me. So if this is my vertex, it also means I'm going to have a line of symmetry running straight through there. So we know our line of symmetry is what? X equal, it's the h value. So that's my line of symmetry. Now, I've got a very wavy line, so go with that. Now what I want to do is pick a point to the right. So if that's 1, I'm going to pick 2 for x. And see where it falls on this graph. Okay, because I'm hoping it's going to be up here somewhere, and then I can reflect it. So we'll see. So let's plug in a 2 for x. I'm going to have to erase. Okay. So if I get my f of 2, then we're going to have 2 times, and what this means is anywhere in this equation there's an x, replace it with 2. So there it is, 2 minus 1 plus 3. Oh, I forgot my squared on both of that. Nobody corrected me. How did you let me do that? Alright, so 2 minus 1 is 1, and 1 times 1, 1 squared, is 1, and 1 times 2 is 2. Okay, now we have 2 plus 3, and that's going to be 5. So if I have an input of 2, I've got an output of 5. So that's the point we're going to graph. There it is. All right, now I've got my vertex, my point. It makes the parabola appear it's opening upwards. Now I'm going to reflect this point. So if I'm 1 unit from the axis of symmetry there with that point, then I have to reflect it 1 unit over from the axis of symmetry to the left, and to reflect that point. And I would pick 1 more point to get something up here and reflect that one too. But for time's sake, I'm going to stop there, and then you connect your dots. Okay, and it should not be in such a V shape. It should be more rounded out. Okay, so make it as round at the bottom as possible. And there it is graphed, and that's all there is to it. But you can't graph these properly without doing some calculations. So when I get papers that just showed this, that's not going to get you any points anymore. Okay? Any questions over that? All right, so we're moving on in our lesson. Yesterday we worked problems, or last week we worked problems 1 and 2. Now we're going to start with 3. All right, interpreting vertex form. So the vertex form of a quadratic equation is written such that we can quickly see the excuse me, the h and k value and get our vertex. So for y equals 3 times the difference of x and 4 squared minus 2, what are the vertex, the axis of symmetry, the maximum or minimum value, and the domain and range? So we have several part question going on here. The first thing is the vertex, next is the axis of symmetry, the max or min, that's going to be one thing, it'll either be maximum or minimum, and the domain and the range. So it looks like we have 1, 2, 3, 4, 5 things to answer here. So let's get started. So you want to first write your equation that they gave you. Okay, there it is. And you want to compare it against the original generic equation. So if we do this, we can quickly see, okay, well, my a value is 3, my h value is 4, and my k value is positive 2. All right, so now I know that my vertex is h comma k, right? So it's going to be 4 and 2. So the vertex is 4, 2. And that means my axis of symmetry runs right through that x value, or here our h value, right? So the axis of symmetry is going to be x equal 4. Now, is it a maximum or a minimum value? Well, let's see. Well, a is positive, and it's greater than 1, so we know it's a stretch, so it's going to be a skinnier parabola. And it's opening upwards. That means that that vertex is going to be at the lowest point of the parabola, so that makes it a minimum value. Okay, so it's a minimum value. But how minimum does it get? Well, it's going to be your k value, which is 2. So k equal 2. I'm sorry, negative 2. Wait. Did I misread this? Oh, guys. K is negative 2. I'm sorry. I missed that. Okay. Told you I do not feel good. I've done this all day long. I make silly mistakes, so you gotta double check me and correct me when you see that I've missed something, okay? All right, so yeah, it's a negative 2. So k is equal to negative 2. Does everybody see that? The k value is negative 2. I have a lot of students say, well, why isn't h negative 4? Because the original formula has the negative sign in it. See, there's not a negative sign with our k value. So that means your k had to be negative 2. So it would have been like it would be plus negative 2. So if you're replacing k, you're replacing it with a negative 2. So your k value is negative 2. All right? Any questions over that? That means your vertex is also for negative 2. So anywhere I left that off, fix that now. Okay? Any questions? Okay, now let's talk about the domain and range. So we know that it was at, let's do it right this time, for negative 2, right? And it opens upwards. So let's talk about domain and range. On any parabola, whether it's right side up or facing downwards, opening downwards or opening upwards, it's going to grow and continue to grow in the horizontal direction throughout infinity. So you can say its domain is going to be all real numbers. And it will always be that for these type of parabolas. Okay, facing upwards or facing downwards. Domain will always be all real numbers, but the range is what becomes different. And you have to look at, well, where does it, range is your y value, domain is your x value. So where does it start on the y-axis? Where does it start? Well, it started at negative 2, right? Right there. So you're going to say my range and I don't think they write this as y equals, yeah, they don't. They're just going to say your range are all real numbers greater than or equal to negative 2. Okay. Previously, we've been writing the range as y is greater than or equal to negative 2. But for some reason they didn't do that here, probably because they didn't graph it. They really didn't use a graph to do this. They went strictly off the formula. I used the graph to help show you how the formula is working. But that's all I can figure why they didn't do it that way. Okay, any questions? All right. So we've learned so far that using this vertex form that there are changes that take place. And if we have a horizontal movement, we're going to see the change. Oops. In the h value, right here. It's going to look like this, y equals x minus h squared. So that's where your horizontal movement shows up inside that parentheses. Right? So that's the thing that gives you your horizontal. The thing that gives you your vertical is the one at the end, outside of the squared, the plus k. And then when you have both types of movements, you're going to see the complete equation. Y equals x minus h squared plus k. All right, so these are the things that we've worked at so far. And then they just add in here what the vertex becomes, but that's pretty apparent. When you move it horizontally and vertically, then your vertex is always just hk. Truthfully, if you memorize this and know how to use it, you can translate any of these equations into that and just use that one all the time. These are sort of shortcuts if you want to look at it that way. Problem 4, using the vertex form, what is the graph of f of x equals negative 2 times x minus 1 squared plus 3? So step 1, you want to identify your constants. So let's do that. So we've got a is equal to negative 2, and we've got an h and a k. So my h is equal to 1, my k equals 3. So we got our vertex right there, 1, 3, correct? So to graph this, I'm going to always start with my vertex. That's why we love the vertex form. So play like this graph isn't there yet, but I would graph that big point right there. There's my vertex. Well, my A value is negative, so I know it's going to be downwards facing. It's going to be a frown parabola. And it's 2, so it's going to be slightly stretched, so slightly skinnier than the parent function. But how much? Well, that's where we've got to go in and grab a point and figure it out. So if we've got this, we can also draw our line of symmetry straight through that vertex. Okay. Excuse me, axis of symmetry. I keep saying line of symmetry. They call it axis of symmetry. Okay, now we need to plot 2 points. So let's just calculate the first one and we'll reflect the second, right? So I'm going to pick 1 to the right of my vertex. So that is at point 2. So I'm going to plug in a 2 for x. So what is my f of 2? So it's going to be negative 2 times 2 minus 1 squared plus 3. 2 minus 1 is 1. 1 squared is 1. 2 times 1, negative 2 times 1 is negative 2. And negative 2 plus 3 is 1. So if I input a 2, I have an output of 1. So over 2 up 1, and there it is. And now that's 1 unit from my axis of symmetry, so I'm going to reflect it 1 unit from on the other side for my axis of symmetry. There we go. Now I've got 3 points. I'm just going to go with that. If you want to be more accurate, I would go out and get 1 more and reflect that, so you'd have the 5 points. But that's all there is to sketching your curve and graphing using your vertex form. Are there any questions? Okay. The last problem I'm going to show you is about a dolphin jump. This is, we can use a vertex form of the quadratic function just to model real-world situations. And here we've got a dolphin that's jumped. And they're showing the first quadrant because truly this graph would have 4 quadrants, right? There's 2, 3, and 4. That's the first quadrant. But in real-world situations, a lot of times they just show our first quadrant. And that's all they're doing here. Because we don't move in negative time and we don't jump in negative heights. So they just leave the negatives off, which just gives us the first quadrant. So if you look at this, if you were to continue this line, it's obvious that this is going to be a parabolic shape of a parabola. All right, so it says the picture shows the jump of the dolphin. What quadratic function models the path of the dolphin's jump? So we can get this and use our vertex form of a quadratic equation. So I'm going to get the vertex. It's at a maximum point right there at 3, 7. So I've got a vertex of 3, 7. Then I'm going to take my vertex form and plug in 3 for h and 7 for k. And that's what they've done here. Now, something else they've done is they've input 9 and 4. Where did they get those? Well, it looks like they're putting in a 4 for f of x or y and a 9 for x. What they've done, see, when they plugged in our vertex with our h and our k, we have a 3 and a 7. Well, we don't know what a is. So what they did is they picked a point in this graph, and they picked right here where it's perfectly crossing at the grids, like right in the middle, at 9 and 4, at the point 9, 4. So they plugged 9 in for x and 4 in for y. And that's what they did here, 4 and 9. Now that they have all those variables plugged in, they can just solve for y. I'm sorry, a. Solve for a. So you get 9 minus 3, which is 6 squared, is 36. So you get a 36a plus 7 equals 4. And now you want to subtract 7 from each side. You get a negative 3 equals 36a Divide each side by 36, and you get a is equal to negative 1/12. So now you've got everything you need. You've got your h and your k, and your a value is equal to negative 1/12. Now I can write my equation, because that's what they ask. What quadratic function models the path? Well, there we go. So it's going to be f of x equals negative 1/12 times x minus 3 squared plus 7. And there's my equation. And that's everything for today. Did anyone have any questions on this one? So you've got to get your points, plug it back in, pick another point, plug that in, solve for a, and then write your equation. Your homework tonight is 4-1 practice K, 10 through 19. So on 10, 11, and 12, you're just going to identify these things: vertex, axis of symmetry, maximum or minimum value, the domain, and the range. So that's 1, 2, 3, 4, 5 things for each problem. Okay, don't cheat there. 13 says, what is the graph of each function? Identify the axis of symmetry. So I want to see graphs, I want to see calculations, whether it's a t-chart or if you're using the formula and solving, okay? Either one. Hopefully you're using the formula for this one. Like, you could label these, you know, there's my h and there's my k. You could do that. A equals negative 1, h equal 5, and k equal 2. I've seen kids do that. But you've got to show me how are you getting your points and how are you calculating your points, just like what I've shown you today. Now, the 16 through 18, they're going to give you graphs, and you're going to do basically what we did in the word problem. You're going to pick values from the graph to help you get the quadratic function in vertex form. And 19 is just error analysis. They're going to tell you a scenario, and you're going to tell them what's wrong about it. So that's everything, and work well.